All right, friends, it's T-Man, and I'm going to do another video on MyloWolf coaching, man. Yes, I guess he's been watching my videos, so he's starting to talk about what I talk about on my channel now all of a sudden. The natty limit. Well, it's not really natty limit, it's the MND size limit. But okay, let's hear him put it together anyways. Let's hear what the fitness slave has to say. The gym lifting fitness slave guy. Pat, I would call him a recruiting slave too, but eh. All right, so MyloWolf of Wolf Coaching says why the natural limit exists. Can we overcome it? I know why it exists, and it's not called a natural limit, dude.
Your worst nightmare. You can't grow muscle anymore. You've reached the natural limit. The truth is, noob gains in the gym.
You never reached the natural limit. That's fake.
Building muscle really fast, it doesn't last forever. Why not?
But that's simply not possible.
It doesn't last forever. It depends what kind of muscle you're building. There are different stages. Listen, there is. I brought this up in my community section way down at the bottom. I've talked about it before. I've done videos. There are different stages in muscle damage, how muscle is built. There's also muscle mass. There's also sarcoplasmic. There's a whole bunch of stuff. There's people getting what we would call an inflammatory response, blood flow restriction, a bunch of phony muscles. The phony look, the phony stuff, transient, the pump, and all that. You understand me? There are different ways of what it is you're trying. Your goal has to be trying to get that what you're looking for. If it's inflaming muscles all day in the gym, well, that's what you're getting. If that's your training, I don't know what your training is really. But anyways, let's hear what it has to say here.
And I don't find this funny anymore.
It never was supposed to be. Why isn't it possible?
It's just not.
Why
It
not,
is
you
possible.
stupid bastard?
Why can't you keep building muscle forever?
You can build it. Here. It's not called natty limit, okay? It's called a myonuclear. Let's get this straight. It's called a myonuclear domain size, okay? And what determines that myonuclear domain size? Well, the progenitor does. It's something called the satellite cell. It oversees this domain. It's so when it reaches it, I'll just read this one part. I've done this before, man. It's get boring after a while. MND size has a ceiling limit during hypertrophic process, beyond which extra myonuclei are donated by satellite cell to do what? To support further muscle growth. So what do you need to support further muscle growth? Well, you're going to need a donation of these nuclei from the satellite cell, but it reached an MND size limit. When did it reach an MND size limit? That is interesting. When did it actually reach an MND size limit? Well, we're going to find out in a second. I need to keep this one on hand. When did it reach an MND size limit? Okay, hold on a second. Just a second. Oops. I don't know why I did that. So you guys probably know this already. It's called myonuclei overload training. It's called myonuclei acquired by overload exercise precedes hypertrophy are not lost on detraining. So there is a map way down here. Way down. There we are. The famous map. So what do they tell you here? They tell you that untrained muscle, first training, and look, the satellite cell. Look, it's fusing. The satellite cell is fusing with what? The fiber. How is it fusing with why is it fusing with the fiber? Why isn't the mass getting bigger? Why isn't mass getting bigger? And what are all these little black dots in there? And then there's all these black dots, and then it says hypertrophy at the top. It says untrained, first training, satellite cell fusion, and then it says hypertrophy. The model for connection between muscle size and number of myonuclei. In this model, myonuclei are permanent. Previously untrained muscles acquire what? Newly formed nuclei by fusion of satellite cell preceding hypertrophy. Why do you need these nuclei? What do? They synthesize protein. Get it? to further that domain. That's what they do. They donate the satellite cells fusing. It's fusing with the fiber. That's what it's doing, okay? So you need to acquire more of these. They tell you here, our data do not support simple the myonuclear. It says here, in which previously untrained fibers acquired newly formed through first training route. This newly acquired nuclei are causally related to the subsequent fiber enlargement. Okay, it reached an MND size limit right here. It reached it at the age of 15, and then it reached it when you first came in the gym. It reached its nuclear domain. It's over. You cannot donate any more extra nuclei to that domain to support further muscle growth. So what do you need to do to get it to support further muscle growth? Well, number one, protein synthesis needs to exceed breakdown. This is the first thing that needs to happen, okay? I'm going to show you. The first thing that needs to happen, this is NCBI. If muscle is going to gain mass, protein synthesis needs to exceed protein breakdown. That is for sure number one. While it may be a common, whatever, but that's the first thing you need, okay? That thing right there. And then you need damage. You need to damage the muscle fibers. You need to damage them so they can donate their nuclei to that domain to support further muscle growth. But only when protein synthesis exceeds that breakdown. You have to push that domain. You got to be at a positive nitrogen balance, meaning that you're anabolic. And of course, this guy in the video, he's going to copy me because you can go look at my last video I did on him. I explained all this already in the last video that I did on his mass thing or whatever he did there. So this is kind of like, he's copying me.
Naturally. Welcome back, DrMiloWolf here with Wolf Coaching, breaking down the science around the natural limit for building muscle. Before we go into why the natural limit even exists, let me
There's no such thing as a natural limit. It's a myonuclear domain size limit. It's nuclear. They're highly myonucleated. These muscle fibers are highly nucleated. Get it, dude?
over the good news. The good news is that you can definitely make gains almost no matter your level of training experience.
No, you can make phony gains and you can misconstrue them for being myofibrillar gains. They could be sarcoplasmic because a lot of people are eating a drug-induced carbohydrate, drug, speed, sugar diet. A legal drug called sugar. Yeah, and carbohydrates, which convert to sugar. It's the same thing, okay? They're made up of the same molecules.
Advanced trainees can likely still gain some muscle. It just takes a lot more time the more advanced you become. What's realistic?
No, it doesn't. It takes the same time. Look, I did a video on sarcoplasmic a couple years ago on my old channel. I did like 5 or 6 weeks of eating like bowls and bowls of potato, and I only worked out 1 day a week. Okay, what am I doing now? Well, I haven't done this in a long time, but I'm damaging muscles and I'm going back to eating lots and lots of protein the rest of the week. The entire week, I'm just eating mounds and mounds of protein. I damaged my muscle fibers though this time. When I come in the very first week, I damage everything and I do it all in unison. I do it in one shot. And then the rest of the week, I'm in protein synthesis the entire week until the repair and the remodeling is over. So I don't have to worry about protein synthesis. It's been extended, blood levels are elevated. So I just keep eating mounds and mounds of protein so that I'm in a positive nitrogen balance, which makes you anabolic, providing you protein synthesis exceeds breakdown. That's it. This doesn't take a genius to figure that out, dude.
Progress to achieve when it comes to muscle hypertrophy and strength gains? Well, a meta-analysis of 200...
No, you could gain hypertrophy. Your muscles can hypertrophy through glycogen. They can load a lot of glycogen in there when you eat carbohydrates, especially starchy carbohydrates, complex carbohydrates. And then you're not strong. You're not strong. You're big, but you're not strong. You're not strong.
Studies or so that
you have chemical strength because you're lifting, so you're getting an adaptation. You're getting better at lifting weights, but you never got physically stronger.
Wormbaum
You didn't build any myofibrillar growth.
and colleagues in 2007 found that on average, across these 200 studies, participants' muscle cross-sectional area increased at a rate of 0.1 to 0.2% on average per day spent training. There's a few...
Yeah, because you're eating an artificial diet, because he just said high volume training. The reason that's happening is because, look, man, this is funny stuff, bro. All this stuff is in science. So if you go to 6 weeks of hypertrophy training, they explain what that is. So if you're a trained individual, your muscles don't get damaged anymore. If you're trained, they do not get damaged, because science tells you what damages muscles. Now, we know eccentric exercise is associated with muscle damage, but not concentric. Muscle fiber hypertrophy in response to 6 weeks of high volume resistance training in trained young men is largely attributed to what? Sarcoplasmic hypertrophy. Get it? Because they're really not eating protein, is not exceeding breakdown, and there's nothing really there going on because they've reached an MND size limit. So no matter how much protein they eat, they can't go past that MND size limit. But they're eating an artificial carbohydrate diet. So a lot of a trained person, they're not damaging muscles, so they're not getting donation of nuclei to synthesize more protein to further that domain. That's number one, because they're trained. Trained muscles don't get damaged. Untrained muscles, unfamiliar and unaccustomed muscles get damaged. You can check in science, unaccustomed exercise is known to cause widespread muscle damage. Okay, dude? It doesn't say trained muscles get damaged. That's why they're getting sarcoplasmic hypertrophy. What is sarcoplasmic hypertrophy? Is a type of artificial muscle growth, dude. That's what it is. That's what it is. See that? Sarcoplasmic hypertrophy is a kind of artificial muscle growth. You train the muscle for another reason than to visually increase the size by increasing the amount of fluid it can hold, but you do not increase the density of the muscle fibers. That's why building muscle is very complex. It's very difficult to build real muscle. It ain't easy. It ain't easy, dude. It's difficult.
Caveats to that number. First, most of these studies included untrained participants.
Yeah.
So if you're untrained...
Untrained. What did I just show you? Nuclei overload. Untrained muscles. They got what? Fusion of nuclei, and then they hypertrophied. Now what happened? They reached an MND size limit. Get it? Everybody calls that newbie gains. They call it my genetic limit, hard gainer, whatever. They give it all these phony names.
And you can use these numbers as a rough guideline, or maybe even adjust upwards slightly.
So what do they do when they reach that domain limit? They start eating carbs like crazy. They start carb loading, and then they go, look, I'm jacked. They're jacked on carbs, dude.
However, if you've been training for a while, it is likely unrealistic to expect quite this much growth. Additionally, depending on...
No. You can get the same amount of growth if you were doing sarcoplasmic hypertrophy, eating bowls and bowls of potatoes all day, working out once a week, and then just loading it because, two, glycogen synthesis needs to exceed that breakdown. It can be extended for an entire week. Science will tell you that. So it just depends on how you're training, what you're doing there. And so that's glycogen. But when it comes to muscle damage, well, yeah, there's a repair and a remodeling there. And blood levels are elevated. Protein synthesis is extended. Not glycogen synthesis is extended. Protein synthesis is extended. And so you need to eat a lot of protein. You need to make sure that you're in a positive nitrogen balance, making you anabolic, and you'll keep growing the whole time. And then you just you once in a while do something you're unaccustomed to and get this damage to come back. Whether it's your chest, back, shoulders, whatever, get it to come back, and you'll get a donation of these nuclei, and you'll be able to further that domain. That's it. It's not hard to do that, but you can do that continuously if you're to work out once a week and allow it to repair and remodel, come back and hit it again. Then you'll just keep pushing that domain week after week after week. You won't have to delay it. That's why it can happen rapidly, providing your training is based on muscle damage training, get it? And not these phony trainings.
How you see it, you could view these numbers as a slight overestimate or underestimate. It's an overestimate in that people generally train harder when they're being observed and are training in the context of a lab, but it's a slight underestimate when you consider that oftentimes in these studies that are doing a single exercise for a single muscle group 2 or 3 times a week. In all likelihood, you're training more effectively than that. And finally, this is an average. You, dear viewer, might be below average, or you might be above average. In all likelihood, by the nature of averages, you're going to be somewhere...
No one's average. You're just... What you're doing is average. You as a person are not average. What is he talking about? You are a human being. You're not average. Your training and the work that you're putting into it may be average. That's all. That may be average. You may be not eating enough. You may not be doing particular things to push that domain. That's it. That's how easy it is.
Around average. But just consider that these numbers don't necessarily apply to you perfectly.
Well, people are just lazy. They opt to take the easy way out. So they're like, I'm going to carb my muscles up. I'm going to carb load. I'm going to carb my muscles up, dude. And they're going to get massive, full of carbohydrates, full of glycogen, 40 pounds of glycogen, like Tristan Lee, like Larry Wheels, 53 pounds at the Golden Griddle. Tristan Lee gaining 40 pounds of glycogen. He didn't get stronger. If he actually gained myofibrillar growth or mass on the myofibrillar or whatever, he would have got, his lifts would have gone up a hell of a lot, because 40 pounds, if that was actual 40 pounds of muscle, believe me, you're going to be a brute. And his lifts never increased, so nothing going on there.
An example of what this 0.1 to 0.2% growth per day really means, let's say you have 12-inch arms and you want to add 2 inches to your arms. How long would that take you based on these numbers?
Easy. It won't take very long at all. It won't take very long at all. You want to know what you do? You're going to carb a lot. That's what you guys are going to do, and they're going to get pumped. I got the pump. I pumped up. You're even going to measure them in the gym like these other knuckleheads, because they got a pump. They're measuring their arms, and look, again, a half an inch. That is so hilarious, man, what people do. I'm telling you, that's like blaha.
The assumptions we make about how much of your arm circumference is made up of bone and fat tissue, let's say somewhere between 50 to 75% of your circumference.
It's also made up of contractile proteins. Did you forget that?
Is muscle tissue. That would mean that adding...
Man, listen, in NCBI, I have it in my community section. It tells you the secondary phase, sarcoplasmic hypertrophy, is not based on contractile proteins. It is not contractile proteins. Myofibrillar growth and muscle damage is associated with contractile proteins. Get it, dude? Yeah, man. And that's what you need to do. You need to damage muscles, but they don't get damaged all the time. And there's something called repeated bout effect phenomena. It protects muscle from repeated bouts of damage and a bunch of stuff.
2 inches to your arms would take somewhere between around 100 to 300 days, or about 4 to 12 months. And to be fair, this is roughly what I expect most beginners to be able to gain.
No, it doesn't. It happens really fast. It can happen really fast if you put the work in. If you actually put all the work into it and not waste your time, then it'll happen very quickly.
In about a year-ish, most beginners, if they're gaining a bit of weight and training effectively, in their first year of training, oftentimes are able to add around 2 inches of arm size. Important.
Yeah, 2 inches of carbohydrate arm size. Carbohydrate arm size. Sarcoplasmic carbohydrate arm sizes. 2 inches. Man, this guy's hilarious. If you could actually build 2 inches of myofibrillar growth on those arms, eating a bagel diet, carbohydrate, sugar diet, well, go for it. Go for it. It's not bioavailable. All these weird carbohydrates, weird plant foods, and everything. They're not bioavailable. Plus, they're all sugar. Sugar doesn't build muscles, man, but they will build phony muscles, though, dude.
This also applies to women. While people often think that women can't gain as much muscle, what have you, in relative terms, they can gain just as much muscle as men. It's just that women have...
Of course they can. Women can gain the same amount if they follow the same procedure.
The lower starting point in terms of overall muscle mass. But in terms of percentage increase from baseline, women gain just as much muscle as men. That was the finding of a recent meta-analysis by Refalo and colleagues on differences between the two sexes.
Yeah, I've read this before. I did a video way on my old channel, way a long time ago.
In how much muscle is gained. In absolute effects, meaning how many kilograms of muscle were being gained, or how much of an increase in muscle thickness there was in terms of centimeters, yes, men gain more, but that is an artifact of their bigger muscles to begin with.
No, that's not necessarily true. They may not gain more. They may gain more and they may not gain more. It depends on what they're eating and what they're doing. If a woman is eating more than a man is not eating as much as the woman, who's gaining more? The woman or the man? The woman. This is just stupid. This is a stupid analogy here. This is a stupid thing.
But in terms of percentage increase, it turns out women and men do gain the same amount of muscle mass. So that's a...
See, they do gain the same amount of muscle mass, men and women. There you go. It's kind of obvious. Hello.
Guideline based on the research of how much progress you can expect to make as a beginner. What about strength? How fast can you realistically expect to gain strength? Well, a big survey by Stronger by Science from a few years ago asked around 1,800 participants how strong they were, and also ask them how advanced they were, so that we can get a rough idea of how much strength people gain in the big three, the squat, the bench, deadlift, based on how long they've been training for. And basically, for relatively untrained men, it's not uncommon to gain around 5 to 10 kilograms on the squat, bench, or deadlift in the first few months of lifting, or the first year or so of lifting. For women, around 3 to 5 kilograms per lift per month is pretty reasonable on the squat, bench, deadlift. However, as people become more advanced, that can slow down quite substantially. And by the time you...
Now that's an adaptation in lifts, man. Listen, that adaptation is not based on mass. Based on lifting is not based on mass. Oh, fuck, man. Christ. That what he's talking about, lifting, like you coming in the gym, getting an adaptation, getting good at lifting a weight, but you didn't get any mass on the myofibrillar, on the limbs. Your limbs didn't grow any mass. Your limbs, your body, your arms, your legs, whatever, they didn't gain any mass. Want to know why? Because myocytic androgen receptor controls the strength. That is in control of the strength, and these motor units, they control the strength because the hormone binds with that receptor. It binds with the receptor, giving you force production. That's what it does. But it controls the strength, but not the mass of the limb muscles. See that? So what controls the mass? If a stronger cannot get you bigger because it doesn't control the mass of the limb muscles, well, what controls the mass? I just told you in the beginning of the video. These myonuclei, they control the mass. They oversee that mass and protein synthesis. When protein synthesis exceeds that breakdown, you're in a positive nitrogen balance, you're anabolic. Now, when they say anabolic, they mean that you have suppressed the catabolic hormone, converted the catabolic hormone to an androgen, so it doesn't have to compete with the what? The myocytic androgen receptor. So if it's not competing with the myocytic androgen receptor, it's making you anabolic. So you have more androgens binding with it. It's going to give you more force production. You're going to be able to damage or whatever, hit the deeper, weaker muscle fibers, and yeah, you can further this domain and it'll get damaged, and you'll get more of these donation of these nuclei, and they'll fill up with the proteins, contractile proteins, pushing that domain, you being in anabolic growth state. Okay, dude, it's not complicated to understand the structure, how this all works, how it comes together. Dude, get it? But he seemingly has a degree and he doesn't know these things.
You've been lifting for say a year or two, for both men and women, you're lucky if you're putting on 1 to 2 kilograms on any given lift per month on average. So
that's a lie. See, I just told you, the myocytic androgen receptor controls the strength but not the mass of the limb muscles. But we do know if mass increases on the myofibrillar, that must make the myocytic androgen receptor, it must get bigger as well. It must get wider. It must get bigger. Plus, it'll donate. If you're anabolic, if you're what do you call it? Oh, fuck, man. I get tired of talking about this all the time. Okay, if your nitrogen balance is positive, and you are anabolic, then it will create more androgen receptors for the hormones to bind to. You get it? Plus, it'll convert the catabolic hormone to an androgen, so it doesn't have to compete with the myocytic androgen receptor, you'll be able to force more weight. You'll be able to lift more weight, okay? You're anabolic now. And you're anabolic and you're growing too. You're growing all the time. You're never not growing, okay?
if you've been lifting for 2 years or so, you might be gaining an additional 10 kilograms or so in a lift per year.
Yeah, you might gain that much if you're eating a bagel diet. You're eating your little carbohydrate diet, and protein synthesis is not exceeding that breakdown. If you're not putting the effort into the formula, then the pie will never it'll never construct itself. The cake will never be constructed. It'll never grow.
If you're lucky, taking your squat from say 405 pounds or 180 kilograms or so to 190 over the course of a year, if you've been lifting for a few years now. Keep in mind with these numbers,
again, how do you make yourself anabolic so you can increase your lifts? You need to be in a positive nitrogen balance. How do you do that? You need to, protein synthesis needs to exceed that breakdown so you can shut the catabolic hormone off, convert it to an androgen, so it doesn't have to compete with the myocytic androgen receptor. Plus, if you're in positive nitrogen balance, you're anabolic, you're gonna get more of these androgen receptors for what? They control the strength. Boom. They get wider and bigger. They're able to accommodate more hormones. Now, if you've converted the catabolic hormone to an androgen, and it too binds with the rest of the androgens, then there's nothing interfering. There's nothing making you weak over there. Get it? So you're going to have more force production and lifting.
There is going to be some degree of survivorship bias in all likelihood. For one, if you don't see good results from lifting, you're more likely to quit lifting altogether. And so the people who quit lifting...
Yeah, they quit because they think that lifting is going to do all these things for them, when really it comes down to money. You need money to eat. You need food to actually create all that stuff. Without the main formula, money, none of these things are going to work, dude, for any of you. Forget it.
Because they weren't making gains, didn't end up putting their numbers into this survey. And secondly, in general, if you're really feeling bad about your lifts, you might not be as likely to actually take the survey in the first place, even if you are lifting consistently. Importantly, this same pattern of rapid strength improvements and then a pretty drastic slowdown in progress is evident in another couple of studies, both in powerlifters and the general population. In a study by Latella and colleagues that I was involved with, we looked at the improvement in powerlifting total from meet 1 to future meets over time, using a huge database of powerlifters. Keep in mind that most people enter their first powerlifting meet when they have at least a year or two of lifting experience under their belt. So we're not talking about ranked beginners here, more so about like intermediates to advanced. On average, from their first competition to about a year after the first competition, most powerlifters gain about 10% on their total. So if you just competed for the first time and your total right now is around 500 kilograms, after a year of powerlifting on top of that, you might expect on average around a 550 kilogram total. The bad news comes after that. To go from adding roughly 10% to your total to roughly adding 20% to your total takes 9 further years. So you go from adding 10% over the first year of powerlifting to adding only an additional 10% over the subsequent 9 years of powerlifting. Those are averages. Your experience might differ. Importantly though, this sort of logarithmic growth increase is apparent in other research as well. For example, I was involved in another study where we looked at data sets of people performing 20 minutes of lifting a week. So really minimum dose sort of lifting. A gym chain in the Netherlands called Fit20 is centered around the idea that people can achieve strength gains by just spending 20 minutes a week lifting. Importantly, the trainers...
Yeah, you can get good at lifting weights if you spend time lifting weights. But if you're serious about, getting bigger and stronger, then you're going to put in the effort, like I said to you.
They consistently take note of how much weight people are lifting. And so we were able to analyze that data set to see how fast people progress as they keep lifting with a minimum dose approach.
They do. Everybody's going to progress. Everybody's going to get good at lifting because your motor units are going to kick in these androgen receptors, giving you maximum force production. That's what they do.
And when rescaling strength as a percentage of baseline, in other words, if you could leg press 100 kilograms when you first started lifting, how does your strength increase over time compared to that? Participants saw an increase in strength of...
Think about it. How will it increase? If we want to do it naturally, how do we increase our strength? Well, if the myocytic androgen receptor controls that strength, but not the mass of the limb muscles, right? But if we're in a positive nitrogen balance, if protein synthesis exceeds that breakdown, that increases the mass. But that also puts us what? That makes us puts us in a positive nitrogen balance, which makes us what? What does science say? Anabolic. Well, if we're anabolic, what does that mean? Well, we're growing all the time. We're anabolic. So that means we've converted the catabolic hormone to an androgen, so it doesn't have to compete with the what? Myocytic androgen receptor. And what is the myocytic androgen receptor responsible for? The strength. Get it, guy? Yeah, man. And that mass, what's responsible for that mass on the myofibrillar? When protein synthesis exceeds breakdown. There you go. How hard is that to understand, dude?
30 to 50% over the first year of lifting. However, after that, if you extend the time frame to 6 years of lifting, they only gain around 50 to 60% of strength total.
Yeah, that's people that aren't doing anything. They're recreational people. They haven't put any effort into it. There's nothing going on there. They got a little bit of something, whatever. They got better at lifting boxes in the factory. Okay, so what?
Those 6 years of lifting. Importantly, they were only lifting 20.
6 years of lifting, man. You're not going to wait 6 years in the factory to be able to lift a box, okay? It's got to happen faster. Your boss is going to fire you.
minutes a week in this study, so I don't think this is going to be representative of everyone's progress.
Whatever.
But it's worth keeping in mind that across multiple studies, both in powerlifting populations that are really trying to get stronger, in populations that are doing more minimum dose training, gains really slow down after like a year of lifting. And the same appears to apply to muscle growth too, and that is where the infamous natty limit comes in. Why does the natural limit...
Again, it's not a natty limit, it's an MND size limit. Can this guy, I thought he had a degree, he's a professor or something. Can he use the proper scientific terminology? Jesus.
exist? Why do gains slow down so much once we spent a year lifting? Well,
Why does it slow down so much in a year? It doesn't slow down in a year. It slowed down already the first couple of weeks. It slowed down. It stopped. It reached an MND size limit in the first couple of weeks. The damage attenuates due to the repeat about effect phenomena. There's no more damage. It says in repeat about effect, with a repeat about, there's no more damage. It protects. It's the protective effect. Man, do I have to bring this up too? There's no more damage, dude. You're not damaging any muscles. People are going to say they're damaging in the gym. They're not damaging anything in the gym. They're damaging their brain. They're getting brain damage. What does it say there? The advancements of understanding the repeat about effect. The protective effect against what? Muscle damage from what? A single bout of eccentric exercise. What is this? The repeat about effect refers to the adaptation whereby a single bout of eccentric exercise protects against muscle damage from what? Subsequent eccentric bouts. Why is that? Because when it got damaged, it repaired and remodeled stronger. So it's now resilient from further assaults, getting damaged. Jeepers creepers, man. This guy's funny. I don't know. I don't know. He doesn't know any of this stuff. It's even in eccentric exercises. If you go PubMed and type eccentric exercise, the whole bunch of things are going to come up and they're going to explain all these things to you, man. Why it's superior, this, that, muscle damage, why it's superior, more mass, more strength, a whole bunch of stuff, myofibular growth, a bunch of things, dude.
What prompted me to make this video in the first place was the publication of a recent paper entitled
I don't believe him. I think he made this public. I think he made this video because he saw my videos. I talk about this all the time in my videos.
The Plateau in Muscle Growth with Resistance Training, an exploration of...
I think he's lying, man. I think he's lying. He saw my videos, man, because I even directed my videos towards him. He's seen my videos, man. It's not like they never seen them.
Possible mechanisms. Let me put this up front. This paper is dense. In fact, here's a graph showing just how complicated the muscle growth process can be and how...
No, it's not that complicated. It's not that complicated. It's not that complicated. He's making it complicated.
many things can play into it and explain why gains slow down over time. I'll give you the summary, but just know, we don't know everything fully yet. And while all the mechanisms I'm about to explain probably have some...
Think about it. Why don't the gains stop when a person's eating a carbohydrate diet? These fat people are eating a carbohydrate diet and they're gaining and gaining and gaining forever. They don't gain more muscle cells. They don't lose them, and they don't gain more of them. The original muscle cells, they just keep getting bigger forever. Why can't muscle cells keep getting bigger like fat cells? Get big and big and big and big like a balloon. Why don't they just keep getting bigger? Because they'll weaken you. That can only happen if there's a mutation. The only way to build more muscle is to get more muscle cells. And the only way you can get more muscle cells is through what? Muscle damage, through myofibular growth. Myofibular growth happens when the progenitor comes out, splits, divides, increases in number, differentiates, whatever, and it divides, splits, divides, and increases in number. It's fibroblast cells, fibroblasts, so forth and so on. There's a thing called myogenesis. I'm going to get into it now in the whole thing in the video, okay? Like I said, it gets boring for me to repeatedly say this over and over again, but okay, just for this video. So yeah, there's a whole cascade of events that are happening when muscles get damaged. If they're not getting damaged, the progenitor ain't coming out. You're a lifting slave. That's it. You're a lifting slave, dude. No matter how much protein you eat, without a donation of these nuclei, you cannot synthesize protein. You cannot support further muscle growth. So it won't matter what you do.
to do with it. Some of them are more likely explanations, and we need further research to fully explain all of this stuff. First, a quick primer on how muscle is thought to grow. Your body is in a constant state of flux. Things are happening all the time. And in fact, within your muscles, muscle proteins are being broken down, which is what we call muscle protein breakdown, and built up, which is what we call muscle protein synthesis, all the time. And whether or not you grow muscle as a result of your nutrition, training, and so forth is really just going to be a matter of those two things. Or at least, that's what we think. We can express that as net protein.
Didn't I say this in all my videos? Net protein synthesis breakdown. Build up and breakdown.
Balance equals muscle protein synthesis minus muscle protein breakdown. If net protein balance is positive, you're growing muscle. If it's negative, you're losing muscle. And importantly, whatever you do with your diet.
Exactly. What did I say in my videos? I say that all the time in my videos. This is the first time he's ever brought this stuff up. I bring it up always in my videos, all the time.
Diet, your training, etc. can influence this equation. If you're eating more protein, congratulations. You've boosted muscle protein synthesis and reduced muscle protein breakdown. The same applies to lifting weights, but it's a physiological.
So that means you're growing then. That means you're in a positive nitrogen balance. That makes you anabolic. That makes a natural person anabolic.
Level. In all likelihood, muscle protein synthesis needs to exceed muscle protein breakdown if you are to grow muscle. In other words, you need to be in a positive net protein balance. So why does net?
Yeah, you need to be in a positive nitrogen balance. He says net positive balance. You need oh fuck man, you need to be positive nitrogen balance. Listen man, here's another thing. In my community section, if you scroll down here, I think I posted this a bit ago. There you go. It says here, how do you increase myonuclei in muscle? Remember, you need these nuclei to support further muscle growth. Okay. The primary way to gain more nuclei is through what? Reasonable amounts of what? Muscle damage. Why muscle damage? Why muscle damage? But the muscles are not getting damaged. They're protected by what? The repeat about effect phenomenon. Get it? Yeah, man. There's no more damage. So what do you do to bring back this damage? What causes damage in muscle fibers? Well, trained muscles, they don't get damaged. So it says here, number 4, over time, it becomes harder to damage your muscles due to what? Repeated bout effect. It becomes harder because it's protected. How does it protect? By growing muscle. When it grows these fibers, these muscle fibers, and they repair and remodel stronger, they're resilient from further assault. It's to carry you through a famine. It's not meant for you to build muscles. But you want to build muscles because you want to get bigger and stronger. Okay. It's unnatural for you to do that. But anyways, yeah, so here's the thing. Let me see. I'll go back to this dude in a second. So what does it say here? When you type this in PubMed, unaccustomed exercise, it says unaccustomed eccentric exercise is known to cause what? Widespread muscle damage. An absolute norm in eccentric exercise is the so-called repeated bout effect. So what causes muscle damage? Unaccustomed eccentric exercise is what causes what? Muscle damage. Are you doing that in the gym? Are you unaccustomed and are you doing unaccustomed eccentric exercises? Or are you accustomed to all your exercises? Get it? Get it? So then there's something called the repeat bout effect, which manifests as a gradual reduction in muscle damage after what? Repeated eccentric exercise sessions. And why is that? Because it's adapted. How did it adapt? By growing muscles. It grew muscles and it adapted. It made you stronger. It made you stronger. Well, you're confused, right? I got stronger? I built muscle, I got stronger? I thought I got better at lifting a heavy weight. Didn't I get stronger lifting a heavy weight, or did I get stronger muscles now that they're not going to get torn and broken and ripped? They're not going to break off the bone or anything like that when I'm lifting a heavy weight. That's the whole point. It doesn't want you to build muscles, but it will repair and remodel it stronger. then it'll make it resilient from getting broken with a second repeated bout. That's why if you lift heavier weights, you won't get injured. If you got enough of this damage, when you got an adaptation in lifting, I can't explain this, it's complicated. But anyways, it's right here. See that NCBI? It's from this part, this section, they pulled it out. It's called muscle damage and inflammation, whatever. It's all eccentric exercise. They tell you here, eccentric exercise damage too. Unaccustomed exercise has been shown to result in temporary repairable skeletal muscle damage. There you go. That's the second part there, right there. It tells you right there. Here's another one, eccentric exercise damage. Humans. It tells you muscle injury. Humans frequently occurs unaccustomed exercise. It occurs with what? Unaccustomed exercise. Hello. Here's another one. Muscle damage nutrition considerations. The most exercise results in skeletal muscle damage. However, unaccustomed exercise or eccentric exercise can cause what? Extensive what? Muscle damage. Okay. They tell you everywhere in science. They never say trained muscles, dude. Get it? Gets muscle damage. Okay. You have to be brain dead. Here's another one. A muscle damage, eccentric exercise, mechanism stuff. All forms of exercise, if carried out vigorously, can become painful, but only one form of exercise, eccentric exercise, if we are unaccustomed to it, causes damage. That's what it says here, the rest of it. Sorry. You're going to have to pop it up. I can't pop up all these things, okay? Here's another one. Delayed onset muscle soreness. This delayed symptoms range from muscle tenderness, debilitating pain, Eccentric contractions, risks, and benefits. They tell you here. Unaccustomed exercise is known to cause muscle damage and delayed pain. Delayed pain. It's associated with muscle damage. And it goes on and on and on and on and on forever. Here's another. Unaccustomed exercise result of significant damage to skeletal muscle and cause delayed onset muscle soreness. DOMS. It causes DOMS. Here's another one. Overuse is associated with structural damage and contractile elements reflected delayed onset muscle soreness. Oh my God, there's a lot of them out there, isn't there? Jeepers creepers, dude. Like, here's another one. They tell you here too, more damage. What is it? Another one, unaccustomed exercise followed by delayed onset muscle soreness and morphological changes in what? In skeletal muscle. What else is causing this muscle damage? Mechanical strain during eccentric exercise cause 1/2 sarcomere malformity, overstretching, and sarcomere beyond whatever. You can read that stuff, dude. Here's another one. Here's another one. Oh, there's another one. Hey, delayed, unaccustomed exercise, pain, soreness, inflammation, blah, 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 blah. Here's another one, PubMed. Exercise-induced muscle damage. Yeah, indeed, occurs primarily from the performance of unaccustomed exercise. Oh, I guess that must be the formula. Duh. That must be the formula. If they tell you here it's unaccustomed exercise consisting of eccentric lengthening muscle contractions often results in muscle damage, well, if they're telling you that, then it must be fucking that. Get it, dude? It must be that. It must be. Look, it's all over. It goes all the way down. Keeps going forever here, okay? I'm not going to go through the whole thing. You go find it yourself. And I'm going back to this video because I'll be here forever, man, doing this crazy video.
Net protein balance tend to reduce and potentially even become negative over time in trained lifters. Why is there a natural limit? Well,
no, in trained lifters it becomes negative. So what do you have to do? Unaccustomed exercise. You have to become untrained. You have to do things that you're unaccustomed to doing. You understand me? You got to shoot for a new adaptation. What's a muscle adaptation associated with? Muscle damage. Hello.
as you keep lifting and you become more trained, your muscles might become a little bit more anabolically resistant. In other words...
No, they don't become more anabolic resistant, man, just because you keep training. They become anabolic when you're in a positive nitrogen balance. Hello.
When you're sending them the signal to increase muscle protein synthesis, as you keep...
No, you don't send them a signal for protein synthesis. When protein synthesis exceeds breakdown and you're in a positive nitrogen balance, there's the signal. There's the signal when you have money and you can afford to eat, you bum.
Training, they become incrementally more deaf and unable to hear you when you tell them to increase muscle protein creation. And
of course they don't hear you. They only hear money. They only hear food. Your muscles only hear one thing. Meat, money, animal protein. If there's not enough of it, they're not going to be listening to you, okay? They're not going to listen to anything you have to say. They're going to laugh at you.
Finally grow
Spending too much time reading
you when you tell them to increase muscle protein creation and finally grow some muscle. As the authors put it, it may be that anabolic signaling pathways become more refractory to loading with chronic training.
No, they don't. They don't become. They don't become fractoid due to training. Well, they do due to training because you're not eating. But if you're eating and you're anabolic in a positive nitrogen balance, then they'll keep going. Is providing you have enough money to eat. But if you're poor, forget it. It'll stop.
Partially explaining muscle growth plateau over time. Importantly, though, both mechanistically and in
Nothing plateaus. Not even in the financial field. Hello. It doesn't plateau. There's no such thing as plateau. And if you do plateau, that's just weird. You don't plateau. You keep making more money. There's no plateau in financial. There's no plateau in muscle growth. It keeps going on forever and ever. You may lose money and you may gain money. You can lose money and gain money all the time. Sometimes you have to lose money to make money. It all depends on what you're doing there. I don't know. So sometimes you need to lose. There's protein breakdown and then there's a window for protein synthesis. But the window for protein synthesis is always higher than the breakdown. So you have that opportunity to put more back into the bank as long as you have more money.
more applied settings, we do have evidence that taking some time off training might decrease anabolic resistance slightly and reset.
No, taking time off just means that the muscles have been repaired and remodeled. They're ready to break down. They break down better when they're broken in unison. It's kind of like an overworking of an untrained muscle or unaccustomed muscle. Let's just put it this way. It's an overtraining of an unaccustomed muscle. How do you do that? By doing the entire upper body in one shot and then doing your legs the next day, but allowing it to repair and remodel. After it's been repaired and remodeled, it'll be ready to break down again. But if it has not been repaired and remodeled, it will not damage with a repeated bout at all whatsoever.
Sensitize your muscles to the muscle protein synthesis response from lifting weights. For instance, a couple of studies by Ogasawara and colleagues looking at the effects of training cessation on subsequent progress suggest that taking some time off in the form of deloads or just time off lifting in general could resensitize your muscles a little bit, allowing you to make...
No such thing. That's all bullshit. They don't resensitize taking time off. You need to eat, man. You need food and all that to eat and build muscles. And if you need damage, they need to be unaccustomed. The exercise needs to be unaccustomed to get that damage to come back, just like science says. They're not lying there, dude.
Progress in the long term. But this remains pretty speculative. We only have a few studies on this, and I wouldn't bank on taking time off really boosting your muscle.
I got enough studies. I can bring out studies and just drown you in them, dude, if I really need to, if I really wanted to.
As long as you're taking the occasional week off training every few months, there's a good chance you're getting this effect already. Next, certain factors might impact the muscle protein breakdown part of the equation. By increasing muscle protein breakdown, you're reducing the amount of muscle growth being seen. Importantly, muscle protein breakdown doesn't seem to change that much as you become more trained. The authors note that it's possible that the AMPK pathway, which is a pathway that gets activated during energy restriction, or cutting for example, becomes a bit more prominent in trained lifters. And so as a trained lifter, potentially getting into a calorie surplus and consuming sufficient protein might be the main things to pay attention to when it comes to minimizing muscle protein breakdown.
No, really? You don't say. Yeah, it kind of does, doesn't it? What if you don't have any money to eat? Should I just be a lifting slave, Mr. MyLoWolf? I don't have any money to eat. Will the weights build the muscles for me? How many reps to build a muscle, dude?
And so if you want to maximize hypertrophy as a more trained lifter, we already kind of knew this anyways, but being at least a bit of a surplus is probably a good idea. And likewise for protein. Protein both stimulates muscle protein synthesis and reduces muscle protein breakdown, both of which contribute to a more...
No, you don't say. Really? He was so busy trying to convince you that weights are going to build something or do something. Now he had to go back to the real science. Food, money is going to build muscles. And if you don't have any money to eat, you can't build any muscles, dude.
Positive net protein balance or more muscle growth. So
you need to be in a positive nitrogen balance. You need to be anabolic. Yes, I agree. Yes. If you're not building any muscles. You're a lifting slave, gym slave, lifting slave, whatever. Wasting your time, wasting your life away in the gym. I've been lifting for 25 years. They're so proud, some people. I've been lifting for 30 years. And that's all you have to show for it? Give me a break, bro. And meanwhile, it's all fake. They didn't build any muscle. They just put on some sarcoplasmic muscle. They're maintaining the glycogen by eating more glycogen. Eating an artificial diet. That's just crazy.
There are a few things that seem to impact both muscle protein synthesis and muscle protein breakdown in more trained lifters that we need to be aware of. And these things influence the natural limit and why we stop growing muscle in the first place. But there are also other more physiological...
Again, there's no such thing as a natural limit. It's an MND size limit. I don't know what he's talking about, but whatever. You can say, I guess he wants to say natural.
Logical or cellular mechanisms that might be at play as to why you eventually almost stop growing muscle. The first one is...
Yeah, you stop growing muscle when you run out of money. Yeah, you stop getting wealthy when you stop making money. Yeah, your business fails when it doesn't make any money. Yeah, when you don't get any money from your job, you're not getting enough pay, and your rent is like more than what you're getting. Yeah, you can't pay your rent. Yeah, you can't eat food either when you don't have any money, dude. Yeah, it's when you have money, you're able to eat more protein. And if you're able to eat more protein, you can keep growing muscles, dude.
Myonuclear domain theory. Let me break down what
myonuclear domain theory. It's not really particularly a theory anymore. They know what it is, actually. They've been doing a lot of studies on it.
And nuclei are. Like every cell, your muscle fiber...
Yes, what are nuclei? Please tell us.
Cells have nuclei, or essentially...
They do. They all have nuclei. They're highly myonucleated. They're nucleated. Okay. Trained muscle. Here's an untrained muscle. Here's addition of myonuclei. You get an addition there. What else do you get there? Depends on how much damage you got there in the beginning. You get a repair and a remodeling. What does the repair and remodeling do? What does that do? Never mind the nuclei. We know that nuclei synthesize protein to further that domain. But what does a repair and a remodeling do to the muscle when it's damaged? Well, it makes it resilient from what? From further assaults. The repeated bout effect phenomenon kicks in. Why? Because it's repaired and remodeled a lot stronger now. It's resilient from getting damaged with a repeated bout. Get it? It's protected. So that's another problem, because you need to get this damage to come back to get what? The satellite cell to donate what? Extra nuclei to that domain to do what? To support further muscle growth. Get it? So no matter how much protein you eat, even if you're anabolic, your lifts may go up. Your B anabolic positive nitrogen balance, the lifts may go up. But that domain may not be pushed because you're not doing unaccustomed exercises, which are known to cause what? Widespread muscle damage. You keep coming in as a trained lifter. Get it? Yeah. And then, okay, so the addition of myonuclei, and then what does it do? It hypertrophies. How does it hypertrophy? Well, these nuclei synthesize protein. That's how they hypertrophy.
Control centers. Importantly, muscle fiber cells are what we call multinucleated, meaning they can have multiple nuclei at the same time. You can view these nuclei as factories. Inside these little factories, new proteins are being synthesized. Importantly,
Yeah, but how do you get a donation of more of these nuclei so you can support that domain, support further muscle growth, Mr. MyloWolf? How do you do it?
Factory, or one nucleus, can only oversee production in so much territory. Eventually, you need to build more factories.
So how do you build them? Why don't you tell the people? I already just put it up. Remember, it's in my community section.
To build enough protein to keep expanding the muscle. And so, in the long term, addition of new factories, or new myonuclei, is important to continue muscle building. Adding new myonuclei is likely what keeps us growing over the long term, preventing us from hitting that natural limit. And that's why taking steroids, for example, seems beneficial in part. It allows you to build new myonuclei.
No, it doesn't. Taking steroids allows you to lift what? Heavier. So you can get a new adaptation because the muscle is resilient from being busted with a repeated bout. So when you're anabolic as a natural person, look, when you're in a positive nitrogen balance, you're anabolic now. How does a natural person make themselves anabolic? Well, when protein synthesis exceeds that breakdown, right? Okay, you're anabolic. Okay, so you've converted the catabolic hormone to an androgen, so it doesn't compete with the myocytic androgen receptor, giving you what? Maximum force production, right? Myocytic androgen receptor, remember, controls the strength, not the massive limb muscles. Okay. So what happens there is now we're able to push that domain because we're anabolic. We've got more strength. Nothing is interfering. We're anabolic. We can lift just as heavy as a person on steroids. And we can get a new adaptation like a steroid guy. Get it? So now that the muscle has repaired itself, repaired and remodeled a lot stronger, it's resilient from breaking. The moment we progressively overload a lot higher, because now we're anabolic, because we're in a positive nitrogen balance, we can push that domain and we can damage the weaker, deeper muscle fibers, and then we can get a donation of these nuclei to support further muscle growth. Plus, protein synthesis is exceeding that breakdown. It is filling up the tank, and we're pushing that domain. That's how you keep pushing that domain to grow.
One of the more likely potential explanations as to why people stop growing muscle or stop growing as much muscle is because they essentially hit a ceiling on how many myonuclei they have around. And if they're unable...
Yeah, they hit a ceiling limit. That's what I just showed you. They had around during hypertrophic process.
Able to add new myonuclei to their muscle, they might no longer be able to add any muscle altogether. As the
Yeah, without nuclei, you can't grow any more muscle because they support muscle growth. They synthesize protein. They support that domain. Okay.
authors put it, it has been proposed that an increase in translational capacity may be crucial to provide additional machinery to support a sustained increase in muscle growth. Increased translational efficiency is sufficient to increase muscle growth initially, but it may not be enough to allow further muscle growth without an increase in ribosome number. Another potential explanation, albeit a little bit weaker, is the sizer theory. The sizer theory essentially states that as a cell grows in size, its rate of growth diminishes, and this would also apply to muscle cells. And so, as your muscle cells get bigger and bigger,
yeah, it does, because a muscle cell can only get so big, and then you need these nuclei to support further muscle growth and a bunch of stuff.
Their rate of growth slows down until eventually it comes to a near halt, explaining the natural limit. Myostatin, a powerful negative regulator of...
No, it doesn't come... Man, if it came to a halt, it was because you didn't push that domain. You didn't get an adaptation. How do you get an adaptation? When you do something you're what? Unaccustomed to doing. Unaccustomed eccentric exercise. Eccentric exercise is known to cause what? Widespread muscle damage. And when muscles are damaged, what happens to the progenitor cell, the satellite cell? It awakens. It's awoken. It comes out of quiescence and does what? Split, divides, increases in number, and then bingo. It repairs and remodels the muscle fibers a lot stronger. They make him really super strong. Okay, now they make him super strong to do what? To prevent you from busting the muscle fibers down so that you can push that domain. But we can force that domain, providing we're in a positive nitrogen balance and we're anabolic. Get it? Protein synthesis exceeds that breakdown. We're completely eating meat all day, all night. We're eating steaks all day, all night, dude.
Skeletal muscle mass may also have something to do with it. But at this point, we don't really know how myostatin changes in more trained lifters. So far, we've identified a few reasons as to why training age can reduce your muscle growth over time. A greater degree of anabolic resistance as you become more trained, for example. Or it could have to do with myonuclear domain theory, where you need to keep adding...
He's just making up stuff. He doesn't really he can't visualize it in his brain. I'm trying to get you to visualize what is actually happening there and trying to get you to understand that this is the mechanisms of why this is happening. Why is that happening? What do we need to do to get over this and get over that? Why does your body, why does it get damaged the very first time? It repairs and remodels a lot stronger, but then it never gets any more damage because it's the protective effect. What's protecting it? The repair and the remodeling of the muscle fiber got stronger. The muscle fiber itself got stronger. You understand me? It got stronger through a repair and a remodeling. It's a defense. It's like a wall, a defense. It's protecting the other muscle fibers from getting damaged. So, and then if they do get damaged, then there's a donation of these nuclei. That you have to get over that wall. You have to climb up over that wall. How do you climb it? Easy. You need to be in an anabolic growth state. None of you are. None of it. You're all pretending. You are all lifting heavy weight in the gym. I'll explain this. They're definitely getting an adaptation and being good at lifting a heavy weight in the gym. A lot of people are doing that naturally. They notice their bench presses are going up and everything they're lifting, but then they go, well, I'm not getting any bigger. You're not getting any bigger because you're not focused on protein synthesis needs to exceed that breakdown. If you were focused on that, right? If you were focused on that and focused on this damage, and you were to do that every week, muscle damage training every single week, well, then you'd be able to push that domain. So you wouldn't just look like a small, strong guy. You'd look like a massive, huge, strong guy, and you wouldn't have to practice at lifting that heavy weight all the time. You wouldn't be slaved to lifting the heavy weight. Because if you could put on 250 pounds of real muscle, I'm not talking about fakey muscles, but real muscle, then you technically should be able to lift that same weight without practice. Without practicing, yes. But Tristan Lee didn't put on 40 pounds of muscle. He put on 40 pounds of glycogen. And that's why his lifts have not gone up anymore. And he can't lift anything heavy at whatever body weight he went up at. He has to practice that lifting still. Because he didn't build any real muscle. He didn't damage muscles repeatedly, repaired and remodeled them, got a donation of this nuclei, support further muscle growth. He didn't do it properly. He didn't do it properly like everybody else out there. Didn't do it properly. Get it?
Nuclei keep growing, or where the rate of growth of a given cell decreases as its size increases. All of these things could be contributing to why more trained lifters see slower growth than less trained lifters.
No, they don't see any because it's protected. It's protected by what? The repair and the remodeling. How is a bone protected after it gets broken? It remodels it a lot stronger in that section. That section will never break again. It's really tough. It's really tough. It's protected now. If you hit that bone area, it's never going to break there again because it remodeled new bone in that area. It made it a lot stronger this time. Stronger than it's ever been before.
However, there's another big component that not enough people really think about, and that is the real killer of gains, father time. As you become older, the condition...
I don't know that. I'm getting older. I don't find that that's a killer of gains, man, but whatever. There's a myogenic decline and then senescent cells, but you can push that if you do muscle damage. It tells you that in the use it or lose it, satellite cell, use it or lose it. It tells you, PubMed, it tells you if you injure these fibers, they come out of quiescent. They remove these senescent cells in myogenic decline.
For growing more muscle become less and less favorable. There are quite a few studies demonstrating less muscle growth in middle-aged to older-aged adults compared to younger adults.
Yeah, I don't know what they're doing because they're getting something called myogenic decline. If you go into this report here, not this one. I don't know what this fucking. I'll look up this one here. Okay, I don't know what happened here.
According to PubMed, in response to injury, satellite cells are able to act.
Okay, so satellite cell in aging. That's what he was talking about, aging, right? We know what the satellite cell does now. It donates its nuclei. It depends when it's damaged. Use it or lose it. Plus, it's in a repair and remodeling. So use it or lose it in aging. What do they tell you here? They said around the age of 30, muscle atrophy is associated with a number of serious morbidities and mortalities. It is. You're going to die without muscle, real muscle. I'm not talking about fake muscles. You're never growing muscles, though. Satellite cells are responsible for regeneration of skeletal muscle and enter a reversible non-dividing state of quiescence under homeostatic conditions. Yeah. That's what it does. In response to injury, listen to what they say here. In response to injury, satellite cells are able to activate and re-enter the cell cycle, creating new cells to repair and create nascent muscle fibers. To repair and create what? Nascent muscle fibers while preserving a small population that can return to what? Quiescence for what? Future regenerative demands. What is this future regenerative demands? It's the satellite cell pool. We're trying to expand that pool for future regenerative demands. I don't know. Maybe you're going to regenerate later in the future. However, in aged muscle, satellite cells that experience prolonged quiescence, if you do not do things that you're unaccustomed to doing, and your muscles experience prolonged quiescence, they will undergo programmed cellular senescence. So how do you get rid of programmed cellular senescence? Well, your training really should be unaccustomed training. You should be trying to eke out these adaptations which are associated with muscle damage. And what causes muscle damage? Unaccustomed exercise, eccentric Exercise is known to cause what? Widespread muscle damage. Now, if you're not doing anything unaccustomed, eccentric exercise, and you're not getting this damage, well, guess what's going to happen? When in aged muscle, satellite cells that experience prolonged quiescence will undergo programmed cellular senescence, an irreversible non-dividing state that handicaps the regenerative capabilities of muscle. That's what's going to happen to all of you if you don't do the proper training. This review examines how periodic, listen to the word, periodic activation. They didn't say consistent activation. They say periodic activation. Why is that? Because it can only be activated periodically. It cannot be activated every single day. So doing this particular stuff, activation, whatever. This review examines how periodic activation and cycling of satellite cells through exercise can what? Mitigate. It can mitigate senescent acquisition and do what? And myogenic decline. What's myogenic decline? Well, the satellite cell is declining. That is a myogenic decline. And then you're going to become an old dude, an old man, an old fart. So if you do this periodically and activate it, guess what's going to do? It's going to mitigate senescent acquisition and myogenic decline. How about that? That's what muscle damage does. The real lifting, not the phony stuff that all you all doing out there with your phony lifting stuff.
Even when exposed to the
So you all go ahead and keep lifting that heavy weight. Be a lifting slave, trying to pursue lifting a heavy weight forever. You're going to have to be there forever to maintain that weight, lifting a heavy weight. And if you don't, it's going to go away. And you're going to get senescent cells, myogenic decline, a whole bunch of stuff. It's going to be horrendous when you get old. It's going to be you're going to be a one sad bunch of people, man. When you hit that, cellular senescence is going to start increasing and myogenic decline. Me personally, I don't want that. I'm fighting that now myself. I went back to doing this muscle damage stuff. I went back to doing it. That's why I'm eating a lot of meat. I'm doing a bunch of stuff, okay? I'm mitigating myogenic decline and the acquisition of these senescent cells. I'm getting rid of them now.
exact same training program. For instance, one study found more growth in a group aged around 25 years old compared to two groups aged either 50 years old or 75 years old. There are many mechanisms behind.
Yeah, because a lot of the stuff that these old people are doing, they're number one, they're not doing unaccustomed exercise, eccentric exercise, which is what? Known to cause widespread muscle damage. What activates the satellite cell? Muscle damage. Man, so they're not mitigating senescent acquisition or myogenic decline. They're not getting rid of myogenic decline. You understand me?
And why this happens. For example,
if you want to Airbnb your...
For example, some studies note that the first fibers to shrink as you age are type 2 muscle fibers, which are lower.
Yeah, you as an ectomorph, you have less type 2, you have more type 1 than type 2. That's a known fact, and science will tell you that.
And therefore account for a larger proportion of your muscle mass. And importantly, age can play into many of the factors I mentioned earlier when it comes to muscle protein synthesis or even myonuclear domain theory. As the authors note, the etiology behind the development of anabolic resistance is likely multifactorial, including epigenetic changes, decreases in satellite cell capillarization, reductions in circulating anabolic hormones, impairments of...
Okay, so what do you need to do to get rid of all these problems? I just told you, muscle damage. Okay, you need to injure the myofibula. If you're not injuring it, then there's nothing going on there, dude. Get it?
Amino acid delivery, insulin resistance, and age-related physical inactivity, which may exacerbate these aforementioned.
Yeah, what did it say? It said when it's prolonged quiescence, will go under what? Programmed cellular senescence. If the satellite cell does not come out, split, divide, increase in number, and do very specific things in the repair and remodeling over time, you don't do it periodically, well, guess what's going to happen? Programmed cellular senescence, dude. Get it? You're going to be an old man.
Factors. Importantly, some of this stuff can definitely be reversed and attenuated with the right training and diet. For example, we have...
I just showed you what the right training was. It tells you right there what it does. It tells you what to do. It's the satellite cell. Use it or lose it. Right there, PubMed.
evidence that older adults require more protein to maximize muscle building. So, if you're somewhat older,
Everybody requires more protein. You need to be in a positive nitrogen balance. Hello, if you're in a building phase.
say above the age of 65 years old or so,
Oh, brother.
you definitely want to consume a bit more protein. Similarly,
Yeah, I would
one of the
think
bigger
so,
reasons
yes.
why older adults tend to lose muscle mass is because of inactivity. So if you just keep lifting into your older age, there's a
Yeah, prolonged quiescence, inactivity, prolonged quiescence. Even people that do come in lifting in the gym, they're adapted. If there's prolonged quiescence of that satellite cell, if it is not like doing something specific, I'm not talking about hypoxia, dude. You're getting hypoxia, inflammatory response, or whatever, RAS, reactive oxygen species, or some shit. Okay. I'm talking about muscle damage. When it actually comes out, split divides and increases in number. That's what it does. Only in muscle damage.
chance you will still be able to gain some muscle mass, or at least mitigate any muscle loss. A decrease in certain hormones is also why aging is worse for muscle growth. Aging past around middle age is typically associated with a 1 to 3% decrease in circulating testosterone levels. Essentially, as you age,
This guy's full of shit. Your testosterone level doesn't go down providing you eat your natural diet, which is protein. If you eat plants, you'll increase. If you eat these drug-induced carbohydrate diets, which are drugs, you'll increase estrogen. It'll lower your testosterone. You'll be screwed. Get it? That's what's causing all these problems. And whatever. Okay.
conditions for muscle building become less and less favorable. In other words, anabolic resistance starts building up. And you can view anabolic
You're anabolic resistant because you're eating an artificial diet. You're not anabolic resistant if you're eating your natural diet. This is bullshit.
resistance, or essentially the degree to which your body resists muscle growth, as more of a dimmer switch than an on or off switch. Essentially, the conditions become incrementally less.
Listen, man, why do they call these vegetables and fruits anti-nutrients? Exactly what they are, anti-nutrient. Get it, dude? They're not bioavailable, so they don't work in people. What's bioavailable? Meaning that it's available, these so-called, whatever is inside those plants, if there are any vitamins or minerals or anything in their amino acids, you can't use them because they're not bioavailable in humans. Hello.
Favorable for building muscle across your lifespan. However, just because they're not perfectly favorable, because you're 30 or 40 years old or 50 years old even, that doesn't mean you can't still.
That's a lie, man. You can reverse all these things. If you read that piece I just showed you by PubMed, it's Satellite Cell User Lose It. It tells you how to get rid of programmed cellular senescence and myogenic decline by activating the satellite cell. Plus, you already know how to be anabolic. Protein synthesis needs to exceed that breakdown. That puts you in a positive nitrogen balance, makes you anabolic. So anytime you need to know how you need to become anabolic, eat protein. Animal protein, beef is the best. As raw as you can eat it, and it's going to take you places you have never gone before as a natural. People are going to think you're on steroids.
Muscle, especially if other factors are in your favor. For example, you just started lifting weights and therefore your new gains are ahead of you. You can definitely make gains even into your 50s, 60s, and beyond. However, if other conditions aren't in your favor, you've been lifting for a while, your nutrition isn't great, etc., the degree of anabolic resistance that you're being exposed to does increase with age. And so
No, it doesn't. He's making that up. It's because the problem is when they're doing these tests, these people are eating an artificial diet. So that's what's making you anabolic resistant. Hello.
authors postulate this: to increase your natural limit and to fight back against.
You are not resistant because if muscles get damaged, that progenitor wakes up, there's a whole cascade of events. Protein synthesis is extended for an entire week. Blood levels are elevated during the repair and the remodeling phase. Always. It's always like that.
Against it most effectively, you need to start lifting early in your life. Essentially, the more time you're able to spend lifting while conditions for muscle building are.
Not necessarily, but it would be good to, get a donation of these nuclei. They tell the kids get them. They get a lot of nuclei because they do a lot of things they're unaccustomed to doing. Playing soccer, swimming, jumping, riding, running, climbing. And they're unaccustomed to doing these things, and they usually get this damage, and they get a donation of nuclei to that domain. That doesn't mean that they got bigger themselves, periodly they got bigger. It does enhance your performance. Nuclei enhances your performance. They do help.
Favorable, and therefore accumulate a large.
Because they can synthesize protein. They can make you stronger.
area under the curve of muscle growth, the higher your natural limit for muscle building will be. So
I'll explain this. Without those additional nuclei, you can't even synthesize more of these androgen receptors. The androgen receptor is a protein. They're proteins. They're made up of proteins. And so if you're anabolic, you're in a positive nitrogen balance. That means protein. So that protein will build those androgen receptors. And they are what? And they control what? The strength. See? What controls the mass? Protein synthesis exceeds breakdown. Hello.
what I'm saying is, if you have kids and they're 2 to 3 years old, better get them to start lifting. If not yesterday, at least today. Don't actually do this unless you want to. So on the first category, you have things like reductions in muscle protein synthesis as you become more trained, and myonuclear.
No, you don't. You don't get less resistance as you become trained. You become lazy. You stop doing things that you're unaccustomed to doing. So you don't get any more of this damage. Hello. You understand me? You need to do things what you're unaccustomed to. If you don't understand what that means, I suppose you go and figure it out. Listen, if you haven't lifted a heavy weight, you may be unaccustomed to lifting that heavier weight. Maybe you did 315, maybe 400, 500 bench press. I don't know. That would be unaccustomed to doing it. But it has to be vigorous. The workout itself has to be vigorous. It has to be kind of like an overtraining of an unaccustomed exercise. That's really what it is, really. They're telling you in science. Overtraining of an unaccustomed exercise will bring back this damage. Okay, but whatever. So yeah. And then he says nuclear domain theory. It's not a theory. You need these nuclei to support further muscle growth.
Main theory impacting your rate of growth, where if you can't add further myonuclei, you may not keep growing. In the second category, you have father time.
I like how he says if you can't add these nuclei, then you can't grow no more. Okay, why doesn't he tell you how to get them? He's never told you in the video at all, anywhere in the video, how to get these nuclei. How do you get them? How do you get them? Where do they come from? Magically, do they appear magically out of the sky? Why are you resistant when you become further trained? You're resistant. MPS to protein synthesis. Why do you become resistant? What's making you resistant? Oh, these nuclei. Oh, I don't have any more nuclei to synthesize protein. Oh, that's why I'm resistant. Hello, this guy, man, come on.
Telling you, sorry man, you're not going to make any gains anymore. So there is a...
Oh, this is the best one. Father Time being a dick. Yeah, I'm sorry, guys. Father Time. That's the end. That's the explanation? That's it? This is it? Why is there a natural limit? Why is there? Oh, man.
Natural limit for everyone out there. It's not the same for everyone, but there is a natural limit. If only because aging takes its toll on everyone. And that's why
there is a nuclear domain limit for everyone out there. Yes, yes, yes.
Natural limit exists. It exists because both physiologically, as you become more trained, anabolic resistance builds up, but also because as you age...
No, it doesn't. No, as you become trained, anabolic resistance grows up. He just told you. Well, this guy's making up shit, man. He just told you without these nuclei, you can't support what? Further muscle growth. He just told you you reached the natural limit, your MND size limit. He told you, he brought up a paper. You need these nuclei to do what? To support further muscle growth. And now he says, well, you became resistant. You became resistant. You're not resistant. You need more nuclei. Hello.
Anabolic resistance builds up. And eventually, anabolic...
I like anabolic resistance. What makes you anabolic? Positive nitrogen balance and protein synthesis, right? Makes you anabolic when it exceeds breakdown. What is he talking about? How you're resistant? You're resistant because you don't have enough nuclei to support further muscle growth. What do you need to do to get more nuclei? Unaccustomed exercise, eccentric exercise is known to cause what? Widespread muscle damage. And what does muscle damage do? Oh, it activates the progenitor cell, the satellite cell. What does the satellite cell do? Oh, it split, divides, increases in numbers, repairs and remodels the muscle fiber stronger, and donates its nuclei where? To that domain. To do what? To support further muscle growth. Oh, how about that, eh? But it only happens in an adaptation. Oh, right, an adaptation. Now, you can do several unaccustomed exercises, mediocre exercises, and do every single exercise you're unaccustomed to doing, get a bunch of these nuclei to that domain or whatever you're doing there. But eventually it'll stop. Okay, what do you need to do? Progressive overload. But not that kind of progressive overload what they're telling you. You need to do progressive overload because you need looking for a new adaptation. That's why you do progressive overload. We're looking for an adaptation, but we need to be anabolic. So therefore protein synthesis needs to exceed that breakdown. You need to eat a hell of a lot. You need to be anabolic the whole time. You need to be in positive nitrogen balance. Okay, dude?
Resistance is high enough that you can't keep gaining any more muscle, and your net protein balance will stagnate and eventually become negative. Wolf Coaching, provider of positive vibes.
And he didn't tell you how to get more of these. He didn't tell you how to get more of these nuclei to support further muscle growth. No. He just gave you a bunch of bad news, and it'll never go on, and you'll become resistant, and that's the end, guys. I'm sorry. It's over.
I hope you enjoyed the video, and now that you're acutely...
Yeah, I enjoyed the video. He didn't explain anything what these things were. I had to actually explain it to you so that you could actually reason with your mind, understand what was really going on there.
aware of your own mortality
Very sad. This is very sad.
and gradual decline to old age, like the video, comment, subscribe.
Decline to old age. There's no old age. It doesn't exist. If you were out in nature, you would be doing things that you're unaccustomed to doing, and hunting and doing weird things that you're unaccustomed to doing. Doing a bunch of things out there. Maybe swimming, running, I don't know, something. But you'd be doing these things and you're unaccustomed to doing them. And you'd get a donation of these nuclei and you would be eating your natural diet, which is a protein diet. So animals, which is animals. And you'd be eating a lot of them. You'd be eating the organs, blood, the meat and everything. And so you wouldn't, that's what's going to make you live longer. That's what's going to get rid of, prolong this quiescence, program cellular senescence, and myogenic decline and all that will go away. That's why people said that a long time ago people lived a lot longer. They may have lived hundreds of years. We don't know. We don't know. But we are eating an artificial diet and we are in prolonged quiescence of the satellite cell. We're not damaging it because we're not doing things we're unaccustomed to doing. And we're not doing it periodically. Periodic, unaccustomed, eccentric exercises, which do what? They wake up the progenitor cell. They wake it up out of quiescence when the fibers are injured, damaged, and a bunch of things. And plus, we're not eating our natural diet, which is animals. We're eating too much carbohydrates, and that increases metabolic rate. We know that low metabolic rate is associated with longevity. We want a low metabolic rate, and we want to get rid of cellular senescence and myogenic decline, and that will carry you and make you live longer. Yeah, man, providing you eat a natural diet. Protein, eat protein, meat, beef. Beef is the best because you can eat it raw. Don't eat any carnivore animals or anything like that. Eat the organs of the beef, of the cow, and eat his blood, drink his blood, eat his organs, and fucking eat his meat, okay? I'll see you in the next one, man. This is not rocket science, okay? Yeah, man.
If you'd like to see me cover any other positive, feel-good topics, leave a comment down below and I'll get to them.
No, I learned absolutely nothing from you, but whatever. I get tired of educating, doing reviews and trying. I have to educate people. I'll see you in the next one. Tell us what you think about that. Like, subscribe, support the channel, comment down below, and tell me what you think about Milo. Why didn't he tell you how to get over that domain? Why didn't he tell you anything? He just gave you bad news the whole time. I gave you good news at least.